This is the Hewlett-Packard HP65, the first fully programmable pocket-size calculator. There are three ways to use the HP65, and Hewlett-Packard has prepared this series of videotapes to help you learn each method of use for this amazing calculator. Stop the tape whenever you like to think for a moment, or to make a calculation on the 65, or to review a section you'd like to see again. Also, we've included several sample problems for you to do, so please stop the tape when you see this sign and complete the problem. These videotapes are for you. Use them in a way that best satisfies your instructional needs. The only additional materials you need are the owner's handbook, the quick reference guide, and an HP65. The 65 welcomes your experimentation. Try what makes the most sense to you. Most likely you'll be right. Pushing buttons will never hurt the HP65. The worst thing that can happen from a mispunched key or a programming error is the 65 will blink its lights at you. The blinking can be stopped by pressing any key. The manual recommends the Clear X key. The calculator is now ready to use again. All the data is still intact except for what was directly involved in the blinking, and usually even that can be recovered. The best teacher is your HP65 itself. Try what makes sense to you. If you make a mistake, clear X, recover your place, and continue. Let's begin with simple arithmetic. After turning the machine on, check that the right program run switch is in run position. This will be the position for the switch until we learn to program the HP65. Let's see how to enter data. Numbers are entered from the keyboard by keying in the digits and decimal point in left to right order. Clear X replaces anything in the display with 0. Negative numbers are entered by keying in the digits and then pressing change sign. As soon as a number is keyed in, it can be operated upon by any of the built-in functions. Most of these are activated by pressing prefix keys before another key. For a function written in gold above a key, press the gold F key, then that key. For the inverse of a function written in gold above a key, press the gold F inverse key, then that key. For a function written in blue on the inclined front face of a key, press the blue G key, then that key. If no operation is appropriate after a number is keyed in, press Enter up. Now key in the next number. Any of these arithmetic operations can now be performed. In this case, we want times. Hewlett-Packard calculators do arithmetic just as you do it. To add 53 and 89, you'd write down 53, and underneath that, write down 89. And then you'd add. It's done exactly the same way on an HP pocket calculator. Key in 53, press Enter up. Key in 89, and then press Add. Do the same thing for division. 105, Enter up. 15. Now divide. The quotient is 7. The simple old-fashioned math notation explains how to use an HP pocket calculator. The numbers first, and then the operations. A simple rule with no exceptions. Try this calculation yourself. Computing with an HP calculator is easy because of the operational stack. The stack consists of 4 data locations called the X, Y, Z, and T registers. Data is shifted and positioned automatically among these locations. The display shows the contents of the X register, but we can imagine the other registers in the stack hovering above the display like this. When a number is keyed into an HP calculator, it is placed in the X register. Pressing Enter up moves this number up to the Y register, leaving a copy of it in X. Keying a new number into the X register leaves the value in Y unchanged. We can combine these two values arithmetically and read the result in the X register. Or press Enter once again and move the data up. Now we can key in a third number. Pressing Enter moves all the data up one place and leaves the X register unchanged. We can key in more data. Repeating the process once more pushes our first entry over the top, and it is lost. This stack of data can be manipulated at any time. We can exchange the values in the X and Y registers by pressing the prefix G and then X exchange Y. We can roll the whole stack down by pressing G, roll down. Or we can roll it up, G, roll up. We can rearrange these numbers any way we please. Pressing Clear X clears only the X register. To clear everything in the stack, press either Gold key and then Clear Stack. Later you'll discover many uses for the registers and motions of the operational stack. But for now, remember that arithmetic operations take place between the X and Y registers, and answers are placed in the X register. Likewise for the other functions in the calculator. The X's and Y's on the keyboard refer to the X and Y registers. For example, the Y to the X key. This key takes the number in the Y register and raises it to the power of the number in the X register. The answer is placed in the X register. The other important thing to remember is the Enter Up key moves data up the stack and leaves a copy in the X register. It gives us an easy way to compute squares. Key in a number, enter up, times. Internal accuracy of the HP 65 is always to 10 significant figures in scientific notation. Scientific notation for a number means writing it as a number between 1 and 10 multiplied by a power of 10. These two digits on the right are the power of 10. 100 million is kept internally as 1 times 10 to the 8th. And 1,000th is kept as 1 times 10 to the minus 3. The HP 65 can handle magnitudes far more extreme than these. It can work with numbers above 10 to the 99th, down to infinitesimals as small as 10 to the minus 99th. We can choose between scientific and fixed point notation for the display. However, in the registers, numbers always have 10 places. With either format, we can display from 0 to 9 places to the right of the decimal, and rounding off is automatic. For fixed point notation with 4 places to the right of the decimal, press Display, decimal point, 4. For scientific notation with 5 places, press Display, then 5. Press decimal point for fixed point notation. Omit it for scientific notation. Entering numbers of very large or very small magnitude requires scientific notation. Key in the significant digits, then press Enter Exponent, and key in the power of 10. For negative exponents, the same procedure, but after we press Enter Exponent, we press Change Sign. For negative numbers, you must change the sign before you press Enter Exponent. Numbers can be keyed in this way no matter what format is specified for the display. Arithmetic is still done the same way. Since we've pushed our numbers up the stack, to multiply the last 2 entries, just press times. Here's one for you. Multiply these numbers together. Here's the answer. Now compute this quantity. We've seen how to enter data and how to manipulate the operational stack manually. The stack also performs many movements automatically. It's these automatic motions that give the stack its tremendous computing efficiency. Let's perform a simple chained calculation and observe what happens in the stack. Here's a column of figures to be added. Key in 52. Press Enter up. Key in 39. Add. Now key in 43. It's not necessary to press Enter. The operational stack moves up automatically after a calculation. Add. Key in 26. And add. Our answer. After any calculation or any data control operation, the stack is prepared to lift. Keying in the next number lifts the stack automatically. When we do anything that shows the HP65 a number is complete, the stack lift is enabled. Sometimes calculations can be done without ever pressing the Enter key. Here's one. Try it. Along with the automatic lift of the operational stack is an automatic drop. Here's another way to do our addition problem. We can enter all the data into the stack. Now add. The stack has dropped down. We can add 2 more times and get our answer. Another capability of the stack can be seen in this example. When the stack drops down, the T register retains its value. There are many clever ways to make use of this feature. At the end of Section 2 in the Owner's Handbook, you'll find an interesting one. The most powerful aspect of the operational stack is its ability to retain and position intermediate results. Look how the stack handles this problem. We add 35 and 80. 115 is an intermediate result. The stack will hold it for us as we continue. Add 45 and 65. The stack always positions our numbers for the next operation, in this case, times. This is the great advantage the stack has over all other data handling methods. We don't have to read out and re-enter data. Retention and positioning of intermediate results is automatic. See how easy it is yourself on this example. Here's a series of keystrokes that solve the problem. The more complex the problem, the more you'll appreciate the capabilities of the operational stack. Here's another time and effort saver, the last X register. Before any calculation is executed by the calculator, the value in the X register is stored in a separate data register, the last X register. Here's how we could have used the key in this previous problem. 3.65 square root G last X recalls the previous value to the X register, and the lift is automatic. so we can add and take the square root. Recovering from errors is another use for last x. Suppose we want to subtract these two numbers. But we multiplied instead. Pressing G last x recovers the previous x, and dividing returns us to our former number. Now we can press G last x one more time, and this time press the correct key, subtract. Use last x to compute this expression. The last x register and operational stack give you several ways to avoid re-entering data. Let's take yet another look at this problem. Since we're going to use 3.65 twice, let's push it up to the y register. Take the square root, then add it to the number in the y register, and square root again. With a sound understanding of the operational stack, calculating is a pleasure. If we don't want to take the time to be clever, or if the data is too complex for our ingenuity, the HP65 has 9 addressable storage registers labeled 1 through 9. Let's store these metric conversion constants. Millimeters per inch. Store 1. The constant is now in storage register 1, and a copy of it remains in the X register. Next, grams per ounce. Store 2, and the constant is stored in register 2, and so on. In the course of a calculation, whenever we need to convert inches to millimeters, just press recall 1. And the HP65 puts a copy of the constant in register 1 into the X register. Because of the automatic lift, everything else in the stack gets moved up, and the conversion to millimeters is completed by merely pressing times. Besides storing and recalling data, we can also do arithmetic between the X register and the storage registers. This is the only time when answers are not placed in the X register. With register arithmetic, answers are placed in the storage register. Here's how it works. To subtract what's in the X register from what's in register 2, press store minus 2. The answer is in register 2. Let's recall it to the display. Likewise, we can multiply what's in the X register times the contents of register 1. Store times 1. The most common use of this feature probably is accumulating and averaging. Use register addition to sum these numbers in register 1. Then divide 5 into the accumulated sum using register division. Recalling register 1 gives the answer. Registers 1 through 9 can be cleared all at once by pressing either gold key and then clear registers. Most of what you've seen here applies to Hewlett-Packard's other pocket calculators, the HP35, HP80, and in particular, the HP45. To fully appreciate the computing power packed into these calculators and the HP65, you must operate them yourself. Then you'll know why Hewlett-Packard calculators are the world's finest.